For many decades, the earliest ancestors of modern digital building design lived entirely within the two-dimensional realm of flatland. Under older CAD standards, like Singapore's CP83-2, an architectural element like a top-hung casement window was drafted as a few flat lines on a rigid two-dimensional layer named Winthiesi. Contractors cannot extract actionable building data or run physical stress simulations from flat ink. This diagram shows the modern solution, the digital model. Moving past flat lines requires three-dimensional representations with true-to-scale spatial relationships. But there is a practical limit to this new 3D world. If a designer attempts to build a hyper-realistic, fully detailed 3D door on the very first day of a project, the sheer volume of data will crash the computer. Because of these computational limits, a digital component cannot be born perfect. It must be carefully raised, allowing its geometric and informational complexity to evolve over the life of a project. We start in the toddler phase, the preliminary design stage. Here, a component's size and location are only approximate. This image shows what an exterior window wall actually looks like at level of development 200. The core modeling guideline at this stage is simple. If actual dimensions are unknown, the designer uses nominal estimated dimensions. This simple block does not need internal layers, glass glazing, or mechanical fittings. It merely needs to span vertically from the finished floor level to the structural slab above. During this early phase, the component's single job is to hold space in the digital world. As the project enters the detailed design phase, the digital component has to fit precisely into real structural openings. This rendering shows the upgrade to level of development 300, where the window gains specified locations and distinct outer geometry. The component is also getting smarter by absorbing non-graphic parameters. The digital window now carries invisible data defining its thermal performance, known as a U value, along with its blast resistance and aesthetic finish. This technical callout shows the highly advanced LOD 350 stage, revealing the arrival of actual panel dimensions and exact anchorage layouts. Yet, National Virtual Design and Construction Guidelines issue a strict warning to designers as the component matures. Do not over-model. Designers are expressly prohibited from building 3D doorknobs or physical ironmongery on a door. Every piece of ironmongery must be logged exclusively as non-geometric text data in a schedule. This strict rule saves massive amounts of computing power. True BIM maturity requires balancing the necessity of a geometric shape with optimal data density. Eventually, the fully matured digital door is perfectly integrated into a finished commercial facility, seamlessly functioning within the physical space. This diagram visualizes the hidden textual DNA that operations teams require, like a 2-hour fire rating and OmniClass code 23.30.10.00. This invisible data supports design for manufacturing and assembly, allowing standard parametric components to be efficiently extracted and used to standardize the physical build. Decades in the future, a facility manager can click on the specific door model and instantly pull up its manufacturer, exact cost, and acoustic rating. Those original two-dimensional blueprints could never answer those questions. A modern building component is ultimately a highly structured, carefully grown database that happens to take the shape of a door.